Global Sustained Ocean Observing. I'm Albert Fisher. I'm the Director of the Global Ocean Observing System Project Office, which is based at the Intergovernmental Oceanographic Commission of UNESCO here in Paris. I'll be the moderator today, and during the next hour, we'll start with a 30-minute presentation from Gary Mitchum on the Global Sea Level Observing System, or GLOS. After the presentation, we'll conduct a question and answer session by chat. I'll moderate and select and ask the questions verbally. I'll try to select questions that are representatives, and we'll attempt to answer as many questions as time permits. The chat window that you can see open now is already open, so if you'd like to start asking clarifying questions during the talk, please go ahead. The session is being recorded, and a link will be posted on the Goose web page. Our presenter this month is Gary Mitchum. Gary is Associate Dean and Professor at the College of Marine Science at Florida State University. Before USF, he was also at the University of Hawaii, where he was Director of the University of Hawaii Sea Level Center. He's an expert in sea level observations and science, but also works on ocean eddies, El Nino, internal tides, and ocean waves. And Gary's the chair of the GLOS group of experts. So Gary, I will pass it over to you, and apologies for the delay in starting.
Thank you, Albert. Just waiting for the slides to come up. Thank you all. As Albert mentioned, I'm presently the chair of the GLOS group of experts, so you should really interpret this talk as representing the group of experts, not just me. If you can see on the slide on the upper right, the outline, brief outline is I'm going to give you some history of GLOS. We're almost 30 years into this program now. The GLOS program predates the beginning of satellite altimetry, all of the things we're doing with GPS now. So I'm going to go from the history into how the mission of GLOS has evolved over the years, what they call the evolving mission. And of course, we only have 30 minutes, so we're going to go through that fairly quickly and end up with the present status, which will show you essentially the data flow into GLOS. And just a moment. First history is the people that really put GLOS together were in 1983, Klaus Werke, who you can see on the right of the screen, was put in touch with David Pugh, who was the director of the Permanent Service for Marine Sea Level at that time. And they began discussions about how we might have a global sea level observing network. This was put forward to the IOC, the International Oceanographic Commission, in 1984 as a proposal. And before we talk about the proposal, though, at this time, Klaus and David were, of course, very senior, well-respected scientists in the international community. I thought you might like to see them a little bit in their younger days. On the right, we have Klaus in the early exploration of what he called the sloshing mode that he later on used to understand the El Nino phenomenon in the tropical Pacific. David on the left is doing some early work on run-up of surface gravity waves, as always impeccably dressed. So moving on. In 1986, the GLOS program was actually formally approved as a program in IOC at UNESCO. This shows Klaus and David at an early meeting of the GLOS group. On the right, the GLOS logo. There's a bit of trivia here, and not very many people actually know what GLOS stands for, what the acronym means. It's not on the logo. The Global Sea Level Observing System, GLOS actually stands for Global Level of the Sea Surface, which Klaus attributed to David back when. The first GLOS group of experts meeting was held in Honolulu in 1987. We can see here we had a total of 12 people. I was at the meeting too, but was only an observer, so I think I was holding the camera here. The second GLOS group meeting, group of experts, we had risen to about 20 people. We'd have to count them. Miami in 1990. The most recent meeting, you can see the amazing growth in GLOS over the years. We now have about 200 people at the GLOS group of experts meeting and associated science workshop at Liverpool last year, 2013. The group of experts itself is a floating sort of group. We call people in. We have a lot of long-term members, but we also have a lot of turnover, depending on what sorts of problems we're working on. And each time we have the meetings now, every 2 years, we have an associated technical or scientific workshop. And as you can see, we have a very large turnout for these meetings, and they're completely international. The GLOS has been very fortunate with the chairs of the GLOS group of experts. We've had long-term leadership from first David Pugh, the founding father in 1986 through 1997 for 11 years, before turning it over to Philip Woodworth, who did it for almost 8 years. Philip actually gave it up in 2003 in favor of Christian LaProvo, who's pictured here on the lower left. Christian unfortunately passed away shortly after taking this on, after just a few months. So Philip took it up again. That's why you have some peculiarity in the dates there. And then Mark Merrifield, the director of the University of Hawaii Sea Level Center, ran it, was the chair of the group of experts for 6 years, up until 2011. So we have very eminent scientists here, very top-level sea level scientists. And in 2011, I took it up. So we've had a great falling off in abilities there, but there's always chance there'll be an election again in 2 years. Now, probably more important than the chair are the technical secretary at the IOC. We've been very fortunate to have 2 very long-serving technical secretaries. First of all, the founding person, and actually Albert Tokachev, who's pictured here on the left. And Albert was actually the person who initially put Klaus and David together, according to a recollection that Klaus wrote about this a number of years ago. Albert served until about 1997. There were a couple of short-time technical secretaries, but we then had Torkel Arab take over in 1999 and is still serving today. So these people are the ones that actually make GLOS work on a day-to-day basis. So that's a bit of history of GLOS. I have a whole lot more pictures I wish I had time to show you, but I needed to keep that part brief. I'd be happy to talk to you more about it later. The GLOS mission, I'm going to talk to you about 3 things. The original vision was really getting data into the permanent service. And then I'll talk a little bit about the game changed a bit with the emergence of satellite altimetry, precise satellite altimetry, especially with the launch of the TOPEX Poseidon mission in 1992. The other part that's more tide gauge related is I put down here 21st century estimates of land motion. Tide gauges have always been measuring what we call relative sea level. I think most of you know what that means. We measure the height of the sea surface relative to the adjacent land. And in order to determine the rate of change of the sea surface, you also need to know if the land is changing, land is vertically changing as well. Prior to the development of GPS, or what we now call GNSS, the estimates were really about all you could do was to apply GIA or the global isostatic adjustment models. We moved far beyond that, and GLOS has been a big player in that. I want to describe that to you. So in 1985, just prior to GLOS, the permanent service for mean sea level. This is not a picture of a few people. This is a picture of the permanent service of mean sea level. David Pugh on the left, who you've seen before, was the director. Philip Woodworth on the right had just joined it. And Elaine Spence in the middle was the person who actually did most of the data collection and archiving. Now, a big part of the initial impetus for GLOS was to try to increase the data flow into the permanent service for mean sea level. They collected monthly mean sea level data from around the world, and it was voluntary contributions. And the idea that Klaus and David had put together was to put together a set of backbone stations, which is the GLOS core network, approximately 300 stations, and to try to increase the rate of flow and to use these stations as the backbone of regional networks that will serve a large number of purposes. It's difficult, according to Philip, it's difficult to quantify how well GLOS did this, but we can look at one thing on this figure. This is a figure from Philip. In 1997, the permanent service for mean sea level held 27,000 station years of data. In 2011, the most recent count that I have, this number had more than doubled. And that coincides with the GLOS time period. As Philip said, it's hard to make a one-to-one correspondence, but I would say that GLOS has either succeeded or has been very lucky. In either case, I call it a success. The tide gauges and satellite altimetry. I subtitled this a little bit tongue-in-cheek as a love story, mainly because I don't think that was necessarily true at first. The initial altimeters, the first altimeter that we were trying to do serious oceanography with was the GeoSat Exact Repeat mission. And it wasn't clear at all to the tide gauge community that these altimeters were going to work very well. And from the altimeter side, you oftentimes had people saying, well, we don't need tide gauges anymore now that we have an ability to measure global sea level from space. So this went round and around for a while, and one thing that I think really helped is Klaus Werke came into my office one time in the late 1980s, and he was concerned that the satellite altimeters didn't have what he called, what we in the tide gauge community at that time would call a datum, a vertical reference level. And of course, the orbits were determined in a vertical reference, in the International Terrestrial Reference Frame, but Klaus was worried about the stability of the reference frame, of the measurements, not the reference frame, I'm sorry, but the measurements. So that led to a long series of calculations where we were comparing the altimeters to the tide gauges. This, as I said, was, I'm going to attribute this to Klaus's idea initially. And in the early part of the TOPEX mission, there was, this is a figure that we've seen many times, the blue dots here are the altimeter tide gauge differences. We're using the tide gauges here as the vertical datum for the altimeter. And we've been looking at this, as you can see, for about 3 years, and we were seeing a substantial drift, apparent drift, in the altimeter data, if you believe the tide gauges, which at that time, I think it's fair to say, a lot of people didn't. When we then discovered, our French colleagues discovered that there had been an algorithm, what was called the algorithm error, coding error, which led to a drift, which is indicated by the red line. This red line is not fit to the data, it's just simply overplotted. And at that time, I think there was a bit of a sea change in that the altimetry community accepted the tide gauge analyses as a very valuable part of their calibration validation sort of effort. And the tide gauge community started worrying a little bit less about we were going to be out of business for the rest of our lives. Now, the other reasons why the altimeters, the other reasons why the tide gauges were considered important by GLOS is there were a number of things that the altimeters probably would not be able to do, at least in any time in the near future. First of all, one of the things that was pointed out was the measurements across what we call choke points. One that most well known is across the Straits of Florida, between the southern coast of Florida and the Bahamas, a very narrow region where the Florida current, which becomes the Gulf Stream, passes through. Tide gauge differences, of course, have been used to monitor transport through here. And given the scale and the proximity to the land and the contamination of the water vapor radiometer, it was not likely that the altimeter would be able to do this. There's hope that in a number of years now, when we start doing swath altimetry, and we're already talking a lot about coastal altimetry, this might change. But at the time when GLOS was being developed, this was considered a key mission for the tide gauge portion of the sea surface height measurement system, which includes tide gauges and altimeters. Also, coastal studies. Again, the same reason, the altimeter can only approach so close to the land before we start getting contamination. We've done much better in that in recent years, but still, it's still a problem. And so there's an issue of being able to work very close to the coast. Finally, sea level extremes. This contains things like tsunamis, also storm surge events. These are things that the tide gauges are going to be very valuable for. This is something I pulled off of one of the tide gauge, the GLOS data centers. This is the real-time data center at Flanders Marine Institute. And here we see several measurements of the at the tide gauges of the Japan tsunami. And the important thing to note here is that these are observed in real time. So these data are actually available for tsunami warning purposes and storm surge purposes. This is a relatively new development. Because if you think back where I started this discussion was we were talking about being able to get monthly mean data into the permanent service from mean sea level at a time scale of years. So this is a major step forward, which I'll say a bit more about in a moment. The second major thing, in addition to our evolving mission, is the land motion at the tide gauges. One of the things that I mentioned earlier is that we think about using tide gauges now as the vertical datum. This was Klaus's idea back in the early mid 80s, late 80s. And that, of course, assumes that the tide gauges themselves are stable. We're very good at fixing the tide gauges to the adjacent land, to the benchmarks. But as I said, how the benchmarks moving is still the issue. This is, in fact, the largest error we presently have in determining the stability of the satellite altimeters. Klaus has been very front and center on developing these measurements as well. On the left here, we have Bill Carter, who was asked by David Pugh. David Pugh at the time was the chair of the GLOS group of experts, and also since the time GLOS has started, the GLOS chair of the GLOS group of experts and the president of the APSO Commission on Mean Sea Level and Tides have coincided and have been the same person. And that was true when David started this as well. So David, actually wearing the APSO hat, asked Bill Carter to talk about geodetic fixing of tide gauge benchmarks, which gave rise to the famous so-called Carter report. That's that wet picture for you here. This was followed up in a meeting in Surrey. I'm sorry, the previous meeting, the first Carter meeting was 1989 in Woods Hole. Then in Surrey, in the UK, we had a meeting in 1993, which gave rise to the second Carter report, again at David Pugh's instigation via the APSO group and the GLOS group. In 1997, there was a third meeting at JPL, which was actually in conjunction with the group of experts' fifth meeting. And this one was definitely driven by GLOS. Now, the net result of all of this is that here, it's from a paper work done in about 1998, about the time these meetings were being held and talking about how can we do the geodetic benchmarking. And we had evolved by that point to using GPS. And at that point, we're also thinking about DORIS, but it's primarily GPS. And this is a figure from a paper that I did many years ago, first attempt to actually try to do this. And you can see those dots on the map. Those were the number of GPS receivers available for this study. We go now to, in 2001, with GLOS as a prime mover, there was a program called TIGA that was adopted as an IGS pilot project in 2001. TIGA, the acronym there, according to Guy Wappelman, is the first two letters of tide and gauge. So I say it TIGA, more appropriately, I think it's TIGA. But at any rate, it was selected as or approved as a permanent service in 2010. And what I'm showing you here is from Guy's website of the number of station files, essentially, that have been collected versus time. Now, if you look in the 1998 sort of frame where I was just pointing to you, you see the relatively small number of stations. I think probably the best number to look at here is the black curve. And so you see that kind of order of a couple of dozen, perhaps. Rising now to 2014, we have nearly 400 tide gauges with a GPS being processed nearby. A phenomenal growth. And again, like I said, with GLOS kind of leading the way, or at least pushing the people who are leading the way. So I'm going to end up by just giving you the present status. In 1994, when GLOS was formed, we'll use this as a benchmark. There were approximately 300 stations. That has evolved. Stations have entered and left, but we're at 290 now. And in 1984, at the beginning of GLOS, of these 300, 200 existed, 100 of them did not exist at that time. And of the 200 that existed, only 150 of those were reporting data, and they're all in very, very delayed mode, sometimes years of delay. So what we have in the next few pages is, as part of our GLOS reporting to the IOC and the WMO, we've produced these reports, and I'm going to go through them for you very quickly. And the first one is, this is the delayed mode, permanent service for mean sea level. These are all the data. If for those of you who know the permanent service, this is not the RLR set, it's the all data set. The RLR set has similar results. So we see here that the progress is pretty good. 209 of the 290 are up to date. So the 150 that we've had reporting data before has increased substantially. Of the 280 of the stations have data, but not necessarily up to date. And those are the ones in the orange categories. And only 10 stations that we do not yet have existing tie gauges. So that 10 down from the 100 that we're missing when we started. The altimeter comparisons, at the time when we were first beginning to do these, back in the early days of the altimeter, we created something called a GLOS Fast Delivery Network that was at the University of Hawaii Sea Level Center. This was begun when I was still the director there. We had a couple of years of funding from the World Ocean Circulation Experiment to begin this kind of monthly turnaround. We called it real time back then. That's no longer appropriate. We'll call it near real time. So approximately a monthly sort of updating. And here we see that this one now, the stations have to be able to report fast enough to do regular updates to our altimeter analyses. And here we see over half of the stations have been updated in a matter of the last few months, and 41 additionally who are not up to date, but they do definitely have data in the data set. And no data from just under 80. Mostly this is because we just don't have the ability to get the data quickly enough from the originators, but still a very substantial data set. At the Flanders Marine Institute that I referred to earlier, these are stations that are reporting in real time. And so the data are coming in, being updated on a daily basis, or even on a more rapid basis in the case of a tsunami. So again, 184 of the 290, almost 200 now. We've gone from, in the beginning of GLOS in 1984, we've gone from 150 stations of 200 existing that delivered data after a number of years. We're now to almost 200 stations that are delivering data in real time. So I think that's a pretty good indication of how far we've come. And the GPS, or the GNSS as we call it now, this is again another look at what the figure I showed you earlier from Guy Wappelman's site. This is only the GLOS stations now. And we see here that we have almost 150 now GLOS stations that are considered to have a GPS nearby enough to use, compared to the beginning of GLOS, where we had 0. This is probably the most rapidly growing area that we have. Now, to finish, we still have a number of stations in GLOS that need to be completed. There are the GLOS standard now for a climate-capable gauge is that it should report in real time, and it should have a co-located GPS. And we have a ways to go in there. We've made a lot of progress, but the main thing here is that we know how to do it. The only thing that's lacking, of course, is as usual funding. More importantly, GLOS has never had any funding to put things on the ground or in the water, a better way of saying it. And the reason, the way it's worked is that we've worked purely on national contributions and also from bilateral sort of help from one nation to another. GLOS has never had funding to do this. They've always been just sort of trying to coordinate and put people together. And I think it's time, if we really want to finish this, we need to get serious about trying to find some central funding that GLOS can use to actually complete the network. But more importantly, if we can get them there in many places, it's maintaining the networks that is important. This is not in countries like the US or France or the UK, but in large parts of the world where we have these stations, the money to maintain the networks is the real difficulty. And that's obviously my pet point these days, so I'm going to leave that as not thoughts for the future, but that one thought for the future. And Andrea told me 30 minutes, and we're right at 30 minutes, so I'm going to stop there, and thank you for your attention.
Thank you very much, Gary. I really appreciate it. That was a very interesting talk, and in fact, the questions are flying already. So maybe we could actually try to answer some of these questions. A lot of them came from the series of maps that you showed. So maybe I think your presentation will show up again on the screen in just a moment. But while we're waiting for it, let me just ask a question myself. GLASS is both coastal and a global observing network, so it has one thing that's quite different from most of the global observing networks, in situ observing networks that we're looking at in Goose. And every single tide gauge is in national waters. That has quite an interesting advantage, and maybe that's why we have so many participants actually, is that this is a network that has always involved the largest number of countries. More than 70 countries are involved in GLASS. So how do you deal with some of those challenges of dealing with so many different countries, of dealing with so many different national waters, keeping the standards, promoting best practices? How has the community really worked on that?
One of the big secrets to this is having a good technical secretary, because all of that communication that you're talking about is what Torkel spends a lot of his time doing. It wouldn't work without him, so that's important. The other thing is that the IOC regions, for example, in the Caribbean, the IOCaribe, these regions, different parts of the world, it's been my experience watching over the years is that you're really better off looking at this sort of problems you're talking about on a regional basis. The challenges in the regions are very different from one region to another. And so with the regional coordinators are a very important resource here. And we always have a GLASS national representative from each of the countries. And that's who you go to. But I found that the GLASS, having good regional coordinators for the IOC regions is probably very important. Let me leave it at that, Albert. Follow up if you like, but that was my first thought on what you were asking.
So obviously there are some data sharing challenges as part of involving so many different countries. And so Eric Lindstrom has a question. It says that he says that 1/3 of the stations in this plot seem to have no data. And I don't know if it was this plot or a previous plot that he was considering. So I think his question is, why are they still considered stations in GLASS if there hasn't been data in a long time?
Okay. Hello, Eric. How are you? I'm not sure which plot we're talking about, but the way GLASS works is, again, we depend entirely on national contributions. There is no funding to go out and do a particular network. There is some national funding from US funding, for example, to the Sea Level Center that has allowed some work over the years in the Pacific and Indian Oceans in particular. But the GLASS has the member states, if they belong to GLASS, and they want the gauge listed, it's very difficult for us to tell them no, and we just simply are going to take it off the map. And from our point of view, it doesn't have data. This is not something that a lot of resources are being thrown at it, because we don't have the resources to do that. And if we had the resources, we could make them work. And so there's not really much of a downside to taking it off the map. And we still view it as a station that we would like to see. The original GLASS plan, David Pugh and Klaus Berkey put this together. It wasn't just simply dots on a map, but there was a political component to it. Is that if each country that had a coastline was going to have or be asked to contribute at least one GLASS station, because the idea was that this station, as I said, was going to form a backbone. And this was the station that we would try to teach and show standards, and then they would use that to develop their own national networks around it. So again, it was a backbone sort of station. In some areas, they don't exist, but we still would like them to eventually. And there was also along the coastlines, for example, if you look at the coastlines of the United States or Japan and other places, not every station is a GLOS station either. There were some spacing sort of criteria that David and Klaus put together back then. So Eric, would you like to have a follow-up?
Well, he does have a follow-up. He says, why is it not a requirement to report data to be part of GLOS? Goose requires data to be available in the system.
It is a requirement. I'm sorry, some of these stations where no data means the station is either not operating or doesn't exist, where we're trying to get a station in there. All of these different stations that I'm showing you, the different maps, we're reporting to different data streams, but reporting data into the permanent service was the GLOS requirement, that delayed mode, and that is a requirement. And whether or not it will report in near real time or real time depends on the capabilities. And we don't have any way to enforce the capability. But returning the data to the permanent service, the final GLOS data center, that is a requirement.
So you exposed very well how GLOS was really designed primarily around climate requirements, around measuring the long, slow changes in sea level. Of course, tide gauges are also used for tsunami early warning to confirm whether a tsunami has been generated. And you mentioned there's a lot more tide gauges than GLOS tide gauges. They're also used for local purposes, for navigation, for example. So how do you juggle these multiple requirements in designing the ideal network? Certainly, there's compromises that must be made. But have, for example, the tsunami requirements really driven a change in the GLOS requirements?
The tsunami, after the Sumatran event, there was a great deal of interest and concern about tsunami warning. And there was, GLOS made a number of contributions there, primarily getting more gauges in some regions where there was now funding available to do that. And in the Caribbean region in particular, there was some progress made in that area in terms of getting more of the gauges in. The other big thing was the addition of the real-time reporting. And that was when the Flanders Marine Institute joined the team, was as part of the tsunami effort. So a new data stream, which was now truly real-time. That was something that we had not attempted before, again, primarily because of resources. And the other coastal sort of issues, and one that I think we could probably get a lot more interest from the nations, is the ability to do storm surge and extreme sort of monitoring and understanding. And if you have a storm surge model, it has to be calibrated. And that means you have to have some sea level tide gauge observations during a few events. And I think we could actually sell a lot of local national interest by talking to them about that. These things occur in a lot more places than the tsunamis do, and a lot more frequently, and can have major impacts on people. We have always been interested for, as you said, in GLOS for the climate sort of purpose. That's not all it is. I mean, it's supposed to serve mini-masters. And one of the reasons we were able to get a number of the gauges installed during the early days from the University of Hawaii Sea Level Center is they didn't allow us to install gauges for climate monitoring. They allowed us to do it because we in turn provided them with tide predictions for harbor navigation. That's serving two masters where they get a product that they can use and we get the data that will be relevant for our climate studies. This does require, though, that the gauges be climate capable, as we call it. And so you don't need everything for a harbor navigation problem that you need for a climate problem, but we try to get both at the same time. I'm sorry.
So in a previous Goose webinar, go ahead.
When you see me look down like this, I'm looking at the speakers, which is you.
Okay. Actually, in a previous Goose webinar, we heard from the Argo network how they had one main mission, which was a climate mission, but they had started expressing additional missions, such as a marginal seas mission or an under ice mission. And I'm wondering if GLOS has given any thought to separating its requirements into these different missions, which might provide a little bit more clarity.
There have been discussions like that over the years. They're really, it's not new. I mean, no offense intended, but we've been asked this question many times over the years. And at one point we had a half dozen different GLOS subsets. You know, there was the subset for altimeter comparisons. There was a subset for choke points. There was a subset for a variety of different things. And we didn't find that it made much impact, to be honest. And so finally at this point, we're still talking about the GLOS core network, and back to the idea that this is not supposed to be all the tie gauges. It's supposed to be the one that you build the local and regional networks around. And so we're not really doing that. I don't think defining gauges as being in one or the other makes a lot of sense, because different gauges will be in multiple sets. There's an incredible amount of overlap. But the idea of how do we communicate this to the users, all these different masters that I'm talking about, I have been trying. We just had the altimetry meeting last month, and one of the things I've had discussions with people there about supporting GLOS for the purpose of comparing with the altimeters. It's something that's one of our submissions, as I would call it. We also need to be having the same conversations with people at the WMO, perhaps. Albert, you would know better than I would know. The WMO about storm surge and extremes. We need to be trying to find different contributions to GLOS. You know, the Argo is a good example. I thought about mentioning it. If you could tell me what is the funding for Argo, basic Argo, the base Argo mission over a year's time, I would guarantee you that we could finish the GLOS network and maintain the whole thing for a fraction of that. But even those small numbers don't exist right now.
So just following up on that, let me come to one of the questions, a specific question from Eric Leliette. Gary, can you discuss your ideas about what support a funded GLOS center could provide?
On a practical basis, we don't have any trouble getting data from the United States, from France, from the UK, from Japan. We don't have any trouble there. If a gauge breaks, they go and fix it. And the GLOS stations are well maintained and they work very well. In some other parts of the country, in some other parts of the world, gauges go down for the lack of very minor maintenance problems. A piece of equipment that costs virtually nothing that they can't afford. GLOS has to then send out messages to national entities asking, does anybody have something that could contribute or donate? It's amazing that we managed to keep it going as well as we do. When I was at Hawaii, one of our stations, a GLOS station, went down, stopped reporting, and it took me a while to find out why. It's because they'd run out of ink for the strip chart where they were recording the data on. They ran out of ink. And so, of course, we bought it and sent it to them. So, Eric, being able to deal with things like that, and you might be surprised to learn how difficult it is to maintain these gauges in some parts of the world. Just being able to jump on things like that immediately. Being able to, one thing that I would like to see focused on the IOC regionals is within each region, in places of the world where one particular country may not have the resources, none of them may have the resources to maintain a network, but I would like to see GLOS actually be able to fund in each region, 1 or 2 traveling technicians, so that each country doesn't have to build up a tide gauge capability. We can do it at the regional level and share it. I think there's an economy of scale there that we could make work very well. And again, not large numbers.
So let me come back to the concept of the multiple uses of the tide gauge stations. I do think it's a good idea, as you mentioned, to try to integrate this better into sort of real-time or more near real-time forecasting of extremes and improving the forecast of extremes. So that's, I think, something that we should continue discussing, Gary. But you know, again, the network was primarily designed to look at climate change. And there's been a bit of a change in the way people perceive climate change. So I was wondering if the network is still the right one to monitor regional sea level rise or to help in adaptation to sea level. And is there any effort to look particularly at the requirements from that aspect, not from the scientific monitoring of sea level rise, but from the point of view of climate adaptation?
That's a good point. I've been thinking about that as well, Albert. It's a very, very good point. This network was created, as I said, pre-altimetry, not just the change in how we're thinking about climate, but pre-altimetry. So this was part of this whole discussion that was had back in the early 90s about what is the role of tide gauges. I gave a talk once to the tide gauge community with the title, intentionally provocative title, of saying, is there a need for tide gauges in the age of altimetry? And so we need to think carefully about that all along. What is the role of this network? It was originally created with the idea that this was going to be the sea level observing network for the future. Altimetry has changed that. So the global sea level, global changes in the volume of the ocean, global mean sea level, is going to be done by altimetry, but with support from the subset of the tide gauge network being used to assess the stability of the altimeters that we're using. So that has definitely changed. The other thing that's changing, though, about the climate view, and one of the things that I think is going to be more and more important, is that any particular location, at not just at regional, but even at a very local scale, is climate is going to change the extremes that you mentioned. How many storms, how many storm surges, those sorts of things, that I think this sort of network, the GLOS network, can still be very valuable for, and not something that altimetry is not going to be as useful for. These high frequency storm sort of events that are changing on a regional scale at the decadal sort of scale. And that, I think, is something we need to start selling better. The other thing is, for all of these kinds of problems, again, we get hung up in thinking, some of us, me as well, I have to be careful not to think about the things that are going on in the US and the UK and France and Japan, et cetera. But building the networks in other countries where the challenges are a little steeper, we still have this very strong need for the GLOS gauge in each region to show them the standard. You know, that here, this is how we do it, you can copy this one. And that training sort of exercise. I did mention GLOS training here. GLOS has also always been very active in running training courses, trying to show people how to install and operate a tide gauge, and also how to make additional use of the data for things like tide prediction and forecast. All those things are important, and as we're addressing the climate problem, the idea that GLOS is going to be what we use to measure global mean sea level, that's not true anymore. But that we still, though, have a very strong mission, I think, on the extremes and changes in storm climate.
So you mentioned, of course, this integration between satellite altimetry, but also gravity, measuring the geoid, and measuring sea level from tide gauges. Do you think the interactions with the satellite community are strong enough? And do you have any ideas about, if not, how that could be strengthened?
I think they're good. I would have been not so sure in 1995, okay, but things have changed. Things have changed completely. Now, the tie gauge community, when we have the GLOS meetings, I see a lot of the same people that I see at the altimetry meetings and the Argo meetings. And we're all talking together. We understand the tie gauges have a role, the altimetry has a role, the Argo, the measuring Argo and gravity, measuring the components to go into the total sea level, which is measured by the altimeter and the tie gauges. I think they're all working quite well together. But again, like I said, I would not have been so cheery about this in 1995. But I think that's all been worked out. I think the communities coordinate and communicate very well.
So we've come a couple of times to the question of cost and actually having a fairly small cost needed to build out the system. There's a comment from Cesar Toro that traveling technicians prove to be quite effective, however too expensive. So right now he's speaking from the Caribbean region. The training of local and national technicians is going on with the tsunami program. Do you want to just respond to Cesar's comment about traveling technicians versus training local?
I think if you have the capability to fund them locally, nationally, then that's not the problem that I'm so much worried about. In some places, that's not an option. I'm glad to hear that it is where Cesar is, and that's the preferred option, doing it at the national level. I would definitely agree with that. But again, though, when we do the funding, we would have to look at it. If the national level is funding their own, as is happening in most countries now, then this is not an issue. If we're talking about funding national level technicians rather than a regional level traveling set, we would just have to look at the cost and try to balance them, and of course just find what the best solution is. I'm perfectly open to either, but the cost benefit analysis I can't tell you right offhand, but we would certainly be happy to look at it. If we had a region where we might need 3 technicians to travel the region, but you only needed 3 in 3 different countries, then splitting them up is fine.
And you've talked also about the challenges of in some developing countries, but if we look at your map, there's plenty of developing countries that have real-time reporting tide gauges. So what are those success stories? What has made that a success versus places where it's been more difficult?
I would have to, this is one of the kind of things where you have to look at each dot. But one of the things that I know from my own experience, which I've been away from Hawaii for a long time now, but one of the things that I think has worked well within GLOS for trying to get these sorts of things done is where you have different sort of bilateral sort of cooperations, where a particular country has coordinated with another country one-to-one. During the time I was in Hawaii, there was a wonderful example in Malaysia where the Japanese created a 5-year bilateral agreement and installed a wonderful tie gauge network. It was incredible. And that sort of success continues on to this day. And so that would be my guess, is that most of the places you're pointing to, you could probably identify a one-to-one sort of nation-to-nation sort of cooperation that happened for some reason. GLOS, we try to put those things together, but again, what I'd like to see is that we had some funding to fill in the holes where we don't have those sorts of activities going
on. We have a question from Mr. Mzrena. How do new stations for the GLOS network get proposed?
I'm sorry, I didn't catch that.
How do new stations for the GLOS network get proposed?
That can happen in basically 2 ways. The GLOS group of experts, we spent in the early years of GLOS, this was a major portion of each meeting. We would go through the station list of order 300. We would go through them one at a time and find out what was the most recent data, what's the status. If there were problems, then we would write letters and ask, is there something that needs to be changed? But bottom line is, a country who has a GLOS made contributions or commitments to GLOS can ask us, we're having a problem maintaining this gauge and we would like to replace it with this other gauge. And then we will look at the history of the gauge and that and have that discussion. Or it can go the other way around, is that if the GLOS group of experts is interested in a particular gauge, they can approach that country and ask, would you be willing to commit to this as a GLOS contribution? So it can go in both directions. But usually, though, for GLOS, though, it will go through the GLOS national contacts.
And where's the list of GLOS national contacts kept, or is that? I suppose I could suggest that we talk to email Torkild for that information.
Yes, Torkild would have that. I don't have it handy, but obviously there are quite a few of them. But Torkild would have that, of course.
Okay, so we'll try to make sure that that information is prominently posted next to this webinar, actually, on GLOS, so that Reina can contact his national focal point for GLOS.
Okay.
We have a question from Nestor Nemes, which is how do we access the data? Where is it?
Okay, that's another to do then here. I just in terms of the putting this thing together, I didn't list websites, but all of these data centers have you can access via the web. So we just need to provide those links, and let's do that. As you said with the national contacts, can we put that up afterwards?
Yeah, absolutely. We can add that information.
Permanent service. Nice.
We have a question from Douglas Kripe, who's from the GEO Secretariat, the Group on Earth Observations, based in Geneva. And it comes back to the questions about data sharing and the difficulties with that. What are the kind of data sharing difficulties that are being encountered? And is there a message for GEO that it can deliver to member governments to try to help with that?
In the past, the main problems that I saw were sharing of the monthly mean data to the final repository, the permanent service, was not problematic. Even the daily sort of data, not usually so. Some countries were worried about sharing hourly data. And in some countries, some of their tie gauge operations were privatized, and the companies wanted to be paid for the data. We of course said, no, this is a GLOS commitment, and so you're required to provide it. But then it becomes down to, well, what were we required to provide? Was it monthly or hourly? And those things have been largely worked out. I would have to check with Torkild again, but a lot of these things that we ran into in the past, I think getting the data in the hourly, the GLOS requirement now has changed to, we are providing high frequency, meaning hourly in our case, high frequency data, and if possible in real time. But again, it comes down to the capabilities more than the willingness, is my sense of it now. There may be some exceptions, but my sense now is it's more about capabilities than willingness.
So maybe I'll ask one final question, which is in terms of the observing technology itself. I don't think you showed us any pictures of tide gauges. Is there any sort of looming technological revolution, or do you think this is going to be, as one of the oldest observing networks for the ocean, something that's going to stay pretty constant in terms of technology?
So I don't know if the slide shows up on the end, the very first slide. There's a tide gauge there that's at in the Maldives. One of my favorites. That was one of the first that was installed in the Indian Ocean when I was running things in Hawaii. And there's actually a GPS receiver there as well. The technology is shifting now more and more towards radar gauges. Over the time period of GLOS, we've gone primarily from still and well float type gauges, then through acoustic, and now into radar gauges. The primary advantage of the radar gauges is they don't require stilling well. You can actually just hang it off the side of a seawall, which means it's much easier to operate in a lot of places. During all these changes, we have very carefully intercompared the different types of instruments. And for the purposes that we're using, even the float type stilling well gauges are still precise enough. It's really an issue of what you can operate effectively in a particular location. So if there's a place where there's an old stilling well with a float type tide gauge properly operated, the data is climate quality. So that's one of the big advantages of using sea level for long-term studies of storminess, for example, storm surges, is that the data is homogeneous, essentially, for back over 100 years. But these days, though, we're moving towards radar gauges, and there's a lot of activity going on now to intercompare and make sure we understand them so that we don't have any jumps in the data set as we shift over to the radar sorts of systems.
Thanks very much, Gary. We've run out of time. I really do want to thank you. It was a great talk, and I think we had a great discussion. I want to thank all of the participants, who were quite a large number this time. And I'll ask you all to join us for our next Goose webinar, which is coming up on the 8th of December, I believe. The slide is about to pop up. And that will be by David Meldrum, who will be talking about a very new type of potential observing technology, which is using submarine cables for ocean observations. It's related, though, because it's also about sea level. Thanks very much, and goodbye to everyone.
Thank you.